9.5 Introduction. First thing we're going to learn is how to derive the quadratic formula. This is not part of the text, but I want everybody to know it. So we start out with ax squared plus bx plus c. Now there will be a quiz on this on Monday. Ax squared plus bx plus c equals 0. Now what we're going to do is we're going to take ax squared plus bx plus c and solve this for x. We're going to do it by completing the square. So first thing we'll do is we're going to divide through everything by a. So we put in divide through by a, and that leaves us x squared plus b over ax plus c over a equals 0. Now we want to take the first two terms, x squared plus b over ax, and make them into a perfect square trinomial, which means we got to get rid of c over a. So we'll have x squared plus b over ax plus c over a minus c over a equals 0 minus c over a, or just negative c over a, which leaves us x squared plus, this is b over a, b over 2, b over a, plus b over ax equals negative c over a. And now we're going to take the two left terms on the left side. We're going to make a perfect square trinomial, which means we're going to take half of the coefficient of x and square it and add that to both sides. So we'll have x squared plus b over ax plus b over 2a, half of b over a squared, equals negative c over a plus b over 2a squared. Okay, now the factor, we factor the left side, and it's simply x plus b over 2a squared. Notice the emergence of b over 2a, which is, of course, the x-coordinate of the vertex, and x equals b over 2a is the axis of symmetry for the quadratic. Okay, now let's work on the right side for a few minutes here. We got negative c over a plus b squared over 4a squared. And then let's rearrange that. X plus b over 2a squared equals b squared over 4a squared minus c over a. All right. Now, I want to take the right side and make it into one fraction. That is the common denominator. So we have x plus b over 2a squared equals, now the common denominator is clearly 4a squared. This fraction has a denominator of 4a squared. This fraction simply has a denominator of a. A divides into this. So the least common denominator for these two fractions is 4a squared. So we're going to have b squared over 4a squared minus c over a times, and we got to multiply it by what's missing from the denominator, so 4a over 4a. Okay. All right, so we have x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Okay, so now we've cleaned up the right side as far as we can go, and we're going to take the square root of both sides. So we take the square root of the left side, x plus square root of x plus b over 2a squared. It's going to equal plus minus. Remember, everything on the right side is numbers. A, b, and c are numbers. The square root of b squared minus 4ac plus minus. Here, I don't know why that c floating up in the air like that. 4ac Now, over the square root, take the square root of the top, square root of the bottom, 4a squared, which is clearly going to be 2a since 4a squared is a perfect square. So we have x plus b over 2a equals plus minus the square root of b squared minus 4ac all over 2a. New page. Okay, we're going to subtract b over 2a because we want x all by itself. So we got x plus b over 2a minus b over 2a equals minus b over 2a plus minus the square root of b squared minus 4ac all over 2a. So x equals negative b over 2a plus minus the square root of b squared minus 4ac all over 2a. Now, this is, of course, is the quadratic formula. You'll usually see it written like this. X equals, with one, everything above the vinculum, minus b, plus minus the square root of b squared minus 4ac all over 2a. Now, I sort of prefer this version here, and the reason is it emphasizes minus b over 2a, namely as the axis of symmetry and the x-coordinate of the vertex. And you can see right away then that if you go plus the square root of b squared minus 4ac over 2a, in other words, you go that far to the right on the x-axis from minus b over 2a, you have a 0, one of the zeros. And if you go to the left, you have one of the zeros. Now, of course, that's what this is all about, finding the zeros, finding the coordinates, finding the values of x for which y equals 0. Nevertheless, because minus b over 2a comes up in just about every version of the quadratic formula that we talk about, I like seeing it here. Anyway, probably you're really curious about something, namely, do we have a formula for ax cubed plus bx squared plus cx plus d equals 0, where somebody did the exact same process and came up with a similar formula, in other words, solved this for x? Well, by golly, they did, and here it is. Now here are the three, let me make this a little smaller so you can see. There's three solutions for x, right? Let me go a little smaller. Is this all three of them? Yeah. Not quite. Don't have it all. One more time. Okay. Now somebody, I'm not sure who, 300-400 years ago, sat down and went through the process that we just went through and came up with the three solutions for a cubic, all in terms of A, B, C, and D. And here it is. Now, aren't you glad I'm not going to make you derive this formula instead of just making you do a wimpy little ax squared plus bx plus c equals 0? Now, if you think you're glad because I didn't make you do this, check this out. Somebody did the same thing for ax to the fourth, ax to the fourth, it's x to the fourth, I guess, ax cubed plus bx squared plus cx plus d equals 0. I don't know why they didn't use AB. I'm not sure. I guess they wanted to assume that A had to equal 1 or whatever. Anyway, so here are the four roots for the quartic, the degree 4 equation. And it just goes. I remember somebody did this probably sometime before the time of Isaac Newton. Worked all this out so they could come up with solutions for a degree 4 equation. Still not done. Still going. Still going. It's like the little Energizer bunny. Doesn't quit. Imagine using this thing. Now, somebody somewhere, I don't know who, I think a guy named Vieta and his buddies, Italians or Frenchmen, they worked all this stuff out. And they may have even used it, all done by hand. But the need to do this was all displaced by calculus. And once you learn calculus, you'll see you're not going to use the quadratic formula or the cubic formula or any of that stuff. You can find the zeros for a polynomial by doing analysis, by doing calculus, and it's really cool. All right, that's enough for that. Now let's get talking about the chapter using the quadratic formula. Okay, so you want to use the quadratic formula only when you actually need it. Okay, so this first example here, let's take a look at it. Let me get here we go. Okay. Now,